Hi, this is Pavel with a C++ exercise. We are going to create a program that checks for anagrams in a string array. Now, anagram is a word that contains the same letters as another word. So, for example, the word form is an anagram to the letter from, because they have the same letters. You can construct from with the letters from the word form, for example. Alright, so that's for those who didn't know what anagram was, and now they do, so they already learned something. And if you stick around, I will also show you how to actually program this. Alright, so first thing first, we will be using a lot of arrays and vectors. So obviously that's gonna be a lot of loops, especially for loops, and you know, some if statements, nothing too major, I guess. Some string manipulation, some character manipulation, so all the fun stuff. So first things, I'm gonna be using Visual Studio as my editor, so you may need to adjust your main function in your whatever program you use, whatever IDE you use to code. Alright, so let's get to it. So first thing, I'm gonna import few libraries. How about string? We will definitely need that. And we will need, like I said, we will use vector, and we will also use array. We will also use the standard library, so let me just do that. Include, and let me see, just for the measure, let's include the IO stream, and there's one library that I'm going to be using to perform some string manipulation, and it's going to be a library called algorithm. We will be using it to, for example, trim spaces and such. And I'm going to be using namespace std, just because I don't feel like typing std the whole time. So let's create the array with the words that we are going to be checking. It doesn't really matter what words you use. I just made some for this exercise, and here they are. So the words are, and my name, and you can notice that some of them have spaces in between. We will, like I said, we will have to trim that and just making it a little more interesting and a little more difficult than just having, let's say, the word, like I said, form, and the word from to be anagrams. Like from, for example, is capital, so technically if you compare them, they would come up as false. So we have to check what the casing is, whether it's lowercase or uppercase. Again, we have to trim the spaces. And also I made it so when you check one word and you find an anagram, for example, the word Pavel is an anagram to, I made up a word called Valop. Once it is found, normally you would assume there is nothing else to be found, and you would move to another word. But the way I have it is that you can have multiple anagrams. For example, Valop and Volap are as well anagrams. So you have Pavel, Valop, and Volap. So in other words, we have to loop through each word to find all the anagrams. Also, what this means is that once I find the anagram, I have to remove it somehow, so I don't check it again. Let's say I find the anagrams Pavel, Valop, and Volap, and then I keep checking total, then check form, something, ABBA, and then I come to Valop, and it will find another anagram to itself. which is voila, but we already found these the first time. So after we find the anagram or the words that are anagram, we have to kind of remove them, so otherwise we could have duplicate values. And also, like, sum and space thing should be an anagram to something in this case. So that's my these are my words, and I'm going to start coding with the trusty vector of strings, and it's going, I just call it a result, and this is gonna be basically, once I find anagram, let's say I find anagram to Pavel, which is Valub, I'll move it to the vector. That's why I have it vector and not as array, because I don't know, you can, like I said, you can have multiple values. I mean, you could have an array with, let's say, 100 elements, and you know that you wouldn't have that many anagrams. But this way, you know, vector is better. It simply adjusts its size. So first thing we need to know, we need to I mean, I have 11 words in the array, but I don't want to hard code it. I know I want to have an array that if I decide to add word or remove some word, I don't have to, you know, hard code the size of it. So we're going to get size of array, and to get the size of an array, I'll call it size, we'll use the size of and the name of the array, which is words, but that itself wouldn't be enough, because this would simply give us a wrong value, and I'll show you what it's actually going to do. Let me just put the let me put a breakpoint over there and actually run it and see. I'll show you what the size of this array is when we just use size of. And it's building. It's taking a little longer. Okay, so if I put my cursor over there, and the size is 308. So what is 308 in this case? Well, the thing is that this is basically considered, I have 11 elements of strings, so it's 11 strings, and so it happens that string is I believe 28, the size is 28, so if I multiply 11 by 28, I get 308, and that is the size of my array. It's basically counting the size of the strings. It doesn't care how many characters there are in each word or spaces or nothing like that. It's a string. It has a size of 28, and there's 11 of them, so it's 11 times 28 gives you 308. So to calculate the size properly, we have to divide by the size of the string. Alright, so just remember, that's 28. The size of the string is actually it's size of, sorry. So if I go and do 308 divided by 28, which is size of the string, I get an 11, which is the number of elements that I have in my array, and that's the number I'm after. Alright, I hope it makes sense. Let me just put a quick comment, I guess. It's a string array, so we divide it by size of string. If it was integer, then we would divide it by size of integer. Alright, so we got the size. Now we can do some looping. So now we have the size, and the next thing I'm gonna do, I'm gonna trim all spaces. Like I said, we have to get rid of these spaces, otherwise like let's say Pavel with all the spaces would not be an anagram to Valub, because the number of characters wouldn't even match, because space is a character. So I'm gonna do a simple loop, integer I equals 0, I is less than the size that we just calculated, and I plus plus, and I'm going to use a method called erase. So it's the words, which is the string, I is the current word that we are erasing or trimming, and in it we will do remove if. We will remove if words of the I, we're still doing the same word, begin, that's the beginning of the word, the spaces, words I dot end, which is the ending of the word. And what we are, so you can see that it says the last, and we now have to kind of define what it is that we are removing. So we do is space. Now this is just one parameter for the erase. This is the beginning parameter. If you look at erase, if I highlight it and press F12, I go to the definition of this method, and you can see that it erases element at where, and it expects parameters that will define the beginning and end. You got it first here and the last. All right, so when we come over here, this is one parameter, which is the beginning of the word, and now we have to do the words I dot end, which is the end of the word that we are doing or trimming. And if you go to remove F, again highlight it, press F12, that works in Microsoft Visual Studio. I don't know about your IDE. You can see that it expects first, last, and predicament. So that's this is a little confusing, and it may not obviously like make an obvious sense what it is doing, but basically we are erasing something, and we are erasing the spaces from the beginning and spaces from the end of the word. So now, after the spaces are removed, we can actually do our main loops. So we will do something like loop through array, starting with first word, right? So which is the element 0. So we will do again the same for loop, and I is less than the size, and I plus plus. Now this would work under if it was just if we comparing one word to the end. However, at the end we don't want to come to the very last word. We want to come to the word from and compare it to the word BAAB. Bob, by the way, is the ABBA anagram. Because if you go all the way to the end and try to compare the next word, there is no next word. So we would get out of bounds. So over here, when it says size, we will do -1. We want to go almost to the end. We want to go one less than the end. Oh, it keeps scrolling back. We just want to come over here. That's the last word that we want to loop through and compare it to the next one. All right, so that's our outer loop, but we also need the inner loop. But before we do declare it, we have remember the vector result. I'm going to put that word that we are currently checking. For example, at the beginning I'll check Pavel, then total, then form. So I'll check Pavel with total, then with form, then with something, with ABBA, and so forth. So the word that I'm checking, I'll put in my result, because I want to have all the anagrams together. So I want to have a vector with Pavel, Valop, and Volab at the end, so I can output it easily. So I will simply do result dot push back, and I will add the word that I am currently checking. All right, so it put the word we're checking into vector. All right, so that's that. So that will move the word into a vector. And now, how do you check whether the words are anagrams? I mean, you have Pavel and you have Valop. Oh, they have the same letters, but in different orders. So if you just check the words, they're not gonna match. What we have to do, we have to get one letter at a time and sort them alphabetically. So the word Pavel will become L A L B O V, right? Yeah, so that's Pavel. Now we come to Valop, and if you do it alphabetically, you'll get the same letters in the same order. Now Alpov matches Alpov. It's an anagram. So that's what we need to do. We need to get one character at a time and sort them alphabetically. But one way to say whether the words even can be anagram is to just get the count of the letters, how many letters they are. Pavel, for example, has 5 letters. The total has 5 letters, so technically by that calculation we still would have to check them because they have the same number of letters. But I don't have to check Pavel with form because form has only 4 letters. So obviously they cannot be anagrams. Something has what, 2, 6, 8, whatever, 9, I think. 2, 4, 6, 8, 9. So obviously 5 is less than 9. They cannot be anagrams. All right. So first thing we can do is simply check the size of the words that we are trying to compare. So we will do. So let's do our loop, our inner loop. So loop through array, starting with the next word in line. All right. So when I'm checking Pavel, I don't want to check it with itself. I want to check it with the next word, and then with the next word, and then with the next word. So to do that, we will do for integer c, for example, equals I plus 1. That's the next word. If I is 0, c is 1, so I refers to Pavel, c will refer to total. Now I have 2 different words, and we will do c is less than size. We can go all the way to the end because again, when I equals from, I plus 1 will equal to Bob. We still can do that because that's the end of the inner loop, which is okay. It's not going to get out of bounds. So C++, and we will do only check if words match when the number of characters match. All right, so we will do if words I, so that's the first word I'm checking with the index of I, that length equals the words C, that's the second word that I'm checking it with, of its length. If they are the same, then maybe they are anagrams, then we can check them. If not, there's no point of even checking that at all. So like I said before, we have to change them to character arrays, or in our case I'm gonna use vectors. So I'll do vector character, I'll call it A, that's gonna be the first word, and vector character B, which is the second word, or it will hold the characters for the second word. So How we gonna do that? How we gonna make them get the characters? Well, we'll loop through them. So we will do for integer, I'll just call it x equals 0. X is less than the length of the word that we are checking. Remember, the length of these two words at this point is the same. If it wasn't, we wouldn't even be here in this loop. So we can simply do the size of or the length of the word. Doesn't matter whether I or C, because the length is the same. So that's the length, and x plus plus. And within the loop, we will do push one character at a time. And we will do the A, which is the first word, push back. Remember, we need to compare the characters. We already have removed the spaces, but we have to compare them in the same case, whether lowercase or uppercase. So we have to make them the same, because again, we want the ABA, for example, which is all capital, be the anagram of BAAB, which is all lowercase. All right, so we will push back, and in it we will do T2 upper, and this is the first word, but we want only one character, so this is the index of I, and one character at a time. Which character? The one that we are looping through. At this point is 0, so for example, when we do in Pavel, we'll do P, then A, then V, O, and L. So we will do the index of X, which is basically like a substring. It's one character. In this case, it will be 0. When the X changes here, when to another iteration to 1, then this X will be 1. So that will give us the next letter in the word. Then when X is 2, it will give us V, and so forth. And we'll do the same for the word B, which is the next word in line. So this will be the word with the index of C. Remember, I and C is the next word that starts with I plus 1. So to upper, and we'll do the words C, and just as before, we'll do the same index, which is X, which is the one character at a time. I'm missing a parentheses there. So it will loop one character at a time for both of the words of I and C, and put them in their respective vector, or vector A and vector B. So at this point, we have them. We have a character vectors, but not sorted yet. But sorting them is not too difficult. So we will just do sort the arrays alphabetically, and we can use the sort function, and for that we will need basically sort the A dot begin and A dot end. We are sorting the whole word, not just a portion of it, but from the beginning to the end. And we will do the same for the B begin all the way to the end. B, of course, B dot end. So now we have the characters in our vector A and vector B sorted alphabetically. Now we can simply compare them whether they match. Compare both character vectors, and that's simply if A equals B, then we have a match. Then we can, if this is true, we have a match. We can move that word, not the word with I. Remember, the word with I is in this case Pavel. Total would not be there because total would not pass through all these checks because it's not an anagram. Neither would form or something or ABA, but when it comes to Valop, it comes over here it matches the length, it gets the characters for both for Pavel and for Valop into the vectors, then sorts them out, and it comes over here, and indeed they match. So now what do? Now we want to move the word Valop, which is the one from the inner loop. That's the next word we check in. That's the C index. We want to move that into our result. So we will do result dot push, not pop, push push back, and what we are pushing the words of C, because now we know that they match. We can add that word next to the original word, which would be Pavel is already there. We put it here in the result. Now we just added Valop to it. So now result will have two words in it. Now remember when I said that after we add the word to the result, we have to remove it from this array somehow, because we don't want to check through it again. We don't want to come here and check Valop with all the other words and actually find a match, because by the end, when Pavel is finished with all the 11 remaining 10 words, Pavel, Valop, and Volap will be in already checked and would be in the result. So the way I figure we'll do it is simply replace the word that we found to be an anagram with an empty or a space. So we will do words C. Right now the word C would be Valop. We'll simply do an empty. So we can check. So when we come over here where it says the length of the words, we can add another check to it, like not only when the length of the words match, but also when the words I is not an empty, because if it is, we already ran through it, so we don't have to do it again. We already took care of that word. So, and that's the logic behind it. So when we come I believe over here, we'll be still in the loop, the outer loop, which is this one. Actually it's this one, sorry. I believe it's this bracket. I can never see them. Yeah, that's the one. So after that, after we finished with this loop, the inner loop, we are going to still within this loop. All right, so 1 2 3 brackets will come over here, and we will do if list size is equal to 1, only the original word is in the result, meaning no match was found. Remember, there will be at least 1, the size of 1, because we are adding one word right here, which is the word that we are checking. But if that's the only word in it, then there is no other match. So that's basically what this is going to mean. So if so we can do something like, if the result.size is greater than 1, then there was some kind of a match, and the result 0, which would be the first word in the vector, is not equal to empty, then we have a match. Remember, even though we are replacing this, let's say this would be after we're done with these, this would be empty and this would be empty. So technically it still goes through. It comes over here and starts checking all the other words from this point on whether they match. and it comes over here and it will actually find that, yeah, it indeed matches. So this is what we are doing. We don't want to consider that to be a match, because all it means is that we remove the word that was an anagram to some other word. So it's not that suddenly there's empty spaces that are actually a match. All right, so that's why we are making sure that we don't consider these empty spaces to be actually a match, or we only consider the actual words, because the spaces just replace the words that we already found. So if this is true, then we have a we found some anagrams, so we can do a cout, something like anagrams, and we can output all the words that are in the result vector. So for integer x equals 0, x is less than result dot size. So if there's 3 words, then the size would be, it would say x is less than 3, and x plus plus. And all we do, we will simply output it. So we will output the result of x, that's the index, and we'll follow it up with an empty space, so they're separated by spaces if there's multiple words, so they're not, otherwise we would have no space. It would say Pavel, and right after that with no space we would say Valop, and after that with no space we would say Volap. So this will output our result, and after that we can go to a new line. So cout, and because we want all these results in one line, so we want the word Pavel, Valop, and Volap all in one line. Then we'll move to the next line. Now, after we're done with this, after we output, if there is any output, we output it. If not, then we'll simply, this condition is not true, it will skip it. We still have to remove the current results from our vector and kind of move to the next word. So we have to clear vector for the next word, and it simply is result dot clear. All right, so I think this should do. Let me build it and run it. Let's see what we get. Okay, build succeeded. That's a good sign. Let me run it. And here I am. Anagrams Pavel, Valop, Volap, separated by space. Anagrams form and from, that's matching. Anagrams something and something. Remember there was a, if you look at the string, it says something here, but a some space thing, so the space was removed, so it's an anagram, and you have the Abba and Bob. And as you can see, we kept the forms, like Pavel is with capital P, and its output with capital P, exactly as it is originally, while Valop and Volap are with lowercase, but we still found them as to be anagrams, which is correct. Okay, so there you go, and let's say we can add some word, something for total. Let's just do something over here. I will do, let me do totals. So which is not an anagram, obviously, but again, we shouldn't have to change the any loops or anything. It should work just fine. So it's found the same number of anagrams as before. Now let me change this to total, but let's say I will do A and T. So it's the total, I guess, and it should find it because obviously it has the same letters as total. And here it is, it found it. So we just added it there and it deals with it dynamically. We don't have to hard code any values for the loops or anything like that. Alright, so there you have it. I hope it makes sense, at least a little bit. I know there's some things that like this, how we trim the spaces. If you use some library like Boost, this wouldn't be necessary. In fact, I'm pretty sure that even Microsoft has some kind of like a macro or something that uses trim or something like other languages do, but this should work across any IDEs and any current standards for C++. So yeah, there you have it. I hope it was helpful. Don't forget to leave some comments. Of course, like the videos if you liked it, and don't forget to share and subscribe. And I'll see you in the next video. Take care.